Hello and welcome to Cambridge Technical Unit 3 Principles of Mechanical Engineering revision session. I will look in this video at orthogonal forces or resolving orthogonal forces. Orthogonal basically means at 90 degrees. So these aren't at 90 degrees, these forces are at a particular angle. And what we're going to do is resolve them into their orthogonal components, their 90-degree components, their horizontal and their vertical components in reference to the particular object on which the force is acting. There is a method, there's a graphical method that you can use to calculate called a force parallelogram. You may have taught this in physics, where you can take the parallelogram of the forces and you can produce a diagram like so, that gives you a sort of idea of where the forces in a particular system go. But in an examination, it's going to always be better to use a calculation method for calculating the orthogonal. So yes, you've got the method one would be your parallelogram or some such method, but again, don't really want you using that method. What I want you to concentrate on is a calculating method by calculating the orthogonals. If we examine this, what we have is, for that particular force, for example, we've actually got what effectively is a right angle triangle. We have some horizontal forces and we have some vertical forces which resolve into an angle of 20 degrees at 50 kilonewtons. So what we want to do is separate this out into that horizontal force and that vertical force, if you will. And how we do that is, well, if we look at it, we've got an angle, we've got a hypotenuse, we've got an adjacent, we've got an opposite, and this is our old friend and I know that you've all got lots of different ways of remembering this. So we've got the opposite, which is the sine. So we take the sine of the angle multiplied by force involved will give us our vertical component. So let's work that one out for you. So the sine of 20 multiplied by 50, so this is almost like a percentage of the force, and we have 17.1. So that would be 17.1 kilonewtons in that direction as part of the overall force in that little system here. We need cosine to give us our horizontal, the adjacent angle. So the cos of 20 degrees multiplied by our 50 kilonewtons, and that would give us 46.98. That would be our horizontal component, if you will. So that's tackled that and that for the first part of the system. We've also got a horizontal and a vertical at 45 degrees at 30 kilonewtons. So let's take do the cos first. Cos 45 degrees multiplied by 30 kilonewtons is going to be equal to 21.21 kilonewtons. That's going to give us that horizontal. So these two working together in that direction. And cos 45 degrees multiplied, sine, looking at the opposite here, find 45 degrees times 30 kilonewtons is going to give us our vertical component, that's that. And of course it's 45 degrees, so it's going to be the same, 21.21. Like so. So these two components will add up. So the 46.98 and the 21.21 are going to add up to give us our horizontal component, if you will, which is going to be in that direction. You have to excuse Percy in the background there, thinks he wants to come for a walk. Gonna have to wait, puppy dog. So, horizontal will be 68.19 kilonewtons, and the two vertical components are acting in opposite directions, so we're going to end up with, whether it's positive or negative, so we're 21.21, 17.1, so we take one away from the other, and I'm looking at minus 4. So that basically gives me that, sorry, just slightly in that direction, so we've got 4.1. Now I've got two choices. I can resolve this angle either by using a squared plus b squared equals c squared, or I can use I've got the opposite and I've got the adjacent, so I can use tangent. And actually I'm going to use both, because I'm going to use one to check the other. So let's have a look at those. So we've got 68.19 squared, 4649.8 plus 4.11, so square that's 16.89. Add them up. That's 69. 4, 6, 6, 6.69. Don't worry, I'm using a calculator for some of these. That would be 68.31 kilonewtons. So we've got that direction at 68.31 kilonewtons because we've done a squared plus b squared equals c squared, and we want to know the direction or the angle in which the tanker is going to move, so we can do the tangent. So 10 minus 1, opposite, 4.11 divided by, so we've got 4.11 divided by 68.19. Clicking calculator in the background there. That gives me 0.0603. Take the inverse of tan of that. Gives me an angle of 3.449 degrees. So we've got 68 kilonewtons at 3. So if we look back at our original parallelogram, we would be looking at 68.31 kilonewtons of force at 3. I want to say 5, but it doesn't round up properly to that. 3.45 degrees. I hope you found that useful.